Yes. Now let's solve question to for to valid anagram. Again, this is the new NEET code series, which will have first a video on on the logic, and then the subsequent videos will be on different programming languages. And so first, what is the question? Is so you're given two strings S and T, and you're to return true if it is an anagram, and there's a Wikipedia. Okay. Yeah, I thought before it used to link to Wikipedia article, but I think they have directly put the definition itself. So anagram is a word or phrase formed by rearranging the letters using all the letters of the original letter exactly once, using all the words. Yeah. So what it is, and if it is an anagram, then you have to return true or else you have to return false. So let's look at anagram. So in anagram, the count of each, well, like each, this one is ANGRM. So you have three A's, one N, 1G, 1M, and Nagaram also has the same count. So how can you do this? As soon as this count, only one thing should come to your mind, which is the hash map. So what we can do is for each letter of input, we can take it to be a hash map and get the count of all the values. So if you do that, what will happen? So yeah, you have A to be 3, you have N to be 1, N to be 1, G R M to be 1, G R and M to be 1. So now what you can do is you can go through the output string, which is Nagaram, and then just subtract the values of that from the dictionary. So what you'll do first is N, so N will become 1 minus 1 0, and then A will become 2, and then you have G 0, and then 1, 2 will become 1, and then you have R 0. Yeah, let's just try to move this bit to the right. Yeah, yeah, R 0, not this. Yeah, you have R to be 0, and then A will become 0, and then M will become 0. Yeah. And so, and then what you can do is you can go through all the values in your hash map and just check if the sum of the values is zero. And if it is zero, then you can return true since it is an anagram. And if it is false, then you can obviously return false because it's not an anagram. So this is one way to do it. And the time complexity of this will be O of S plus T, because we have to go through all the values of S and T exactly once. The space complexity will also be the same, which will be it will technically not be S of T, but it will be uh, it will be constant, which is it will be O of 26. Because whatever we do, we only have to store 26 letters, mainly because in the question itself it's given that S and T are lowercase letters. And this will also solve our follow-up also, like if it contains Unicode characters and all, then our solution will work in this case also. This is one way to do it, but there's another way to do it, and let's go through that also. So what we can do is, yeah, you can have an array of size 26, and for simplicity, let's take our S to be ABC. So over, yeah, why does this always come? Yeah. So your yes is ABC. Oh my god, just type, man. What is wrong with this? I think I have to use a new application. This is very frustrating. I'm actually re-recording the same video twice because of this issue. Oh my god, yeah. Let's take S to be ABC or ACB and T to be the same. S and both are the same. So what you can do is now you can have an array of size 26, and for simplicity again, let's take an array the size of the array to be 4. Yeah. So what you can do is take the value of A, the ASCII value of A is 65, B will be 66, and C will be 67. Let's again move this to bit to the right. Yeah, 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 will be 67. So what we can do is we can take the entire value of, let's just make it a bit smaller. Yeah. So now what we can do is we can take the character. Let's just go through C once. So we'll take C and then we'll subtract it with the ASCII value of A always. So 65 minus 67 will be 3, will be 2. So what will happen? This will become 1. So we'll subtract it and put a value of 1 over there, plus 1. And then we'll go for B. A minus B is 65 minus 67 minus 65, which is 1. And C, A minus A is 1. So yeah. And if you see how the logic goes, every value from A to Z will, since there are no characters from A to Z, we can store all of them in a single array itself rather than hash map. And by using the formula, the ASCII value of the character minus the ASCII value of small case a. And this will only again work if it is given that S and T are of lowercase letters only. Yeah. And then what you can do is you can go through the output string, which is also ABC. And for that one, in each position, you'll just subtract one. And at the end, what you can do is you can again iterate through the entire string, entire array once, and check if all the values are zero. And if they are not zero, then you'll return false. So you might think, okay, let's just do a sum itself rather than what do you call, uh, like going through each value once and then checking if it is zero or not. But why sum will not work is, imagine you had in such a way that there were two A's and then there were two, like input string was of 2A. Let's just, yeah. Imagine the input was 2A. Yeah. Now again, let's imagine input was 2A's and output string was 2B's. So what will happen now is when you do sum, you will obviously reach zero. But it is obvious that A and B are not anagrams of each other. And that's the reason you can't directly do a sum. You have to go through each value and then just check if it is equal to zero. Yeah, that is it for the logic part. Now I'll upload the solution to this in the multiple languages which I feel are good. And yeah, that's all for it. And thank you for watching.